Okay, so I have shared that screen there. Yeah, everyone see that screen here?
Yeah.
Yeah.
One, yeah, cool. Okay. So here's a question here, just a quick recap on what we went through yesterday. So this is working. Yeah, it is. Cool. All right. So we have subnet, class C subnet, 200.1.1.0, breaking the networks of 40 hosts. So first of all, are we looking to subnet based on the number of hosts or so based on the number of subnets? Or the number of hosts or the number of networks? Well, it says 40 hosts. So the requirement is we must have 40 hosts in each subnet. So always you subnet based on the requirement. We've got one class C network with 256 addresses. We need to divide it into more subnets, but each subnet will contain at least minimum 40 hosts. So again, determine the number of hosts, 40, and convert into binary. So you have your table. 128, 64, 32, 16, 8, 4, 2, and 1, and you have 40. Okay. So you ask yourself, how many bits does it take to make 40? So 0, 0, 1, 0, 1, 0, 0, 0. Yeah. Is that okay? Now is the time, guys. Either use the chat or let me know in audio if you need me to go over anything if I'm going a little bit too fast. So 40 in binary is 101000. To check that out, you can just add the values that have the 1 bits beside it. So you have 132 and you have 18. 32 plus 8 is equal to 40. Okay. So how many bits does it take to make 40? 1, 2, 3, 4, 5, 6. 6. Are we looking for 6 bits of ones or 6 bits of zeros? 6 bits
of zeros.
So I'm going to say 6, 0 bits. Okay, cool. All right. Next part. First part is done. Second part. Reserve those 6 bits in the subnet mask and find the increment value. Okay, so our normal subnet mask is a class C. So we have to reserve those bits. So we just say, okay, so the class C, we'll write down the subnet here. We say 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 0, 0, 0, 0, 0, 0, 0, 0. Yeah. Now it's saying we must have, so this is our default subnet mask, which is a /24, but it's saying our new networks will have at least 6 0 bits. That's what it says. So you have to save those 6 zeros. 1, 2, 3, 4, 5, 6. You start on the right. You know why? Because your ones have to be kept together and the zeros have to be kept together. So you have 6 bits of zeros. Whatever's left, the other 2 zeros can be turned into your new subnet bits. That goes from a /24 to a /26 because you're borrowing 2 subnet bits, or you're robbing 2 subnet bits. You're taking from the host bits and you're adding to the subnets. To get your subnet mask, you just superimpose this here is 0, 1, 1, 0, 0, 0, 0, 0, 0. So your new subnet mask is going to be 255.255.192. That's it. Yeah. Your increment, find the increment. Again, what is the increment? The increment is a numerical value in which your new subnets will increment by. Okay, increment value is always the last subnet bit converted into decimal, which is 64. So this means our new subnets will increment in the value of 64. And because it's a class C, your increment will also be the number of addresses in your subnet. So we're going to have our new subnet will contain 64 addresses in each subnet. Does that satisfy a requirement of 40 hosts? Yes, it does. Okay, and then you just write down your subnet addresses. So subnet number 1, 200.1.1.0. Subnet number 2, 200.1.1.64. The very last address is going to go to 200.1.1.63. Is that okay? Anything there on that you want me to go back over below before we look at something different?
No, all good.
Good. Good.
Explain
Okay.
how do you get the range again, please?
So the range is the increment, yeah. So the increment is always so use the increment. So how do you find your increment? Your increment is always the last subnet bit converted into decimal. So it's your last one over here. You keep going until you get to one bit here. It's the very last one, and then you convert it into decimal. So your increment value is 64. That means your new subnet will increment in the value of 64. Okay. Is that okay?
Mm-hmm.
Cool. All right. Now we're actually going to look at questions that are going to be a little bit easier than them. And this is the more the next type of questions we're going to be looking at is more indicative of what you get asked on the actual exam. Okay. So basically the questions will be that we've already have a host PC. It's already been subnetted, and we need to find out based on the subnet mask what network this PC lives on. Okay, so we have an IP address of a host, and we have its corresponding subnet mask, and we need to find out what subnet this PC lives on. When you're doing this, it's really one thing you need to do. Find the increment. That's what you have to do. Find the increment. Once you find the increment, everything else will fall into place. Okay. Find the increment value. Okay. So it's like reverse engineering. We have the subnet mask. We need to get the increment value from the subnet mask. Now, there's a few ways we can do this. One of the ways is we can take 255, this subnet, and convert back to binary. So the table, 1 sec. 128, 64, 32, 16, 8, 4, 2, and 1. 255 binary is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Dot 224. Okay, so 224 in binary is 1, 1, 1, 0, 0, 0, 0, 0. Yeah, that subnet mask 224 is 111 0, 0, 0, 0, 0. Now remember what I said the last time. When you have a proper subnet mask, your ones will always be together. 111 0, 0, 0, 0, 0. That's a proper subnet mask. And once you hit your first 0, everything after that is going to be zeros.
32.
So the increment value is
32.
32. And again, just to check that is the correct increment. If I add 128 plus 64 is 192 plus 32 is 224.
224.
Is that okay? Now, one or two of you might have spotted that there's an even better way of finding the increment value when you have the subnet mask. An even easier way. So we'll just say the increment value here was 32. An easier way is to take 256 and subtract it by the last number in the subnet. That is not a 0. So 224. 256 minus 224 is 32. And that always works. So the increment value is, so you take 256 minus the subnet mask. If it's, as long as it's not a 0, it'll work. 256 minus the 224 is 32. So our increment value is 32. Okay. So what does that mean? That means our new subnet will increment in the value of 32. So we need to find out what subnet, what area does this PC live in? So where do you start? You start at 0 because 0 is the perfect starting point. And you have to keep going until you find a subnet that will accommodate this PC. So you can start here. You say network number 1, 192.168.1.0. Now, but again, as well, where is the increment in? What octet's in? Is it in the first or the second or the third or the fourth? It's 32 in the fourth octet. Fourth. The third is there. So if I like, this is what this subnet looks like. 1, 1, 1, 0, 0, 0, 0, 0. So that's the first octet. That's the second. That's the third. The increment is 32, which is this guy here in the fourth octet. Does that make sense? It's incrementing in the value of 32, but it's in the fourth octet, this one here. So you say network number 1, subnet number 1, subnet number 2, subnet number 3, subnet number 4, subnet num 5. 192.168.1.0, 192.168.2.0. No, sorry, what am I doing? 192.168.1.0. What am I doing? I'm incrementing the value of 32. My new subnets are going in the value of 32. So 1.0, 1.32. The next network, 192.168.1.64. 192.168.1.96. Next subnet. 192.168.1.96 and 32 is
128.
128. Yeah. So where does this PC live? We call him Bob. Where does Bob live? Does he live in subnet number 1 or 2 or 3 or 4 or 5?
4.
He lives on 4, yes. Because subnet number 4
ends on 127.
exactly. And everything else in between that is part of subnet number 4. 192.168.1.127. And Bob is somewhere towards the end. He's here. Okay, now, so there's a few things you need to be aware of. You need to find the increment because the increment will tell you the numerical value in which your subnet will increment by. It does exactly what it says on the tin. That's why you call it the increment. So you know what it does by the actual, the word it does. Another thing, you always have to start at 0. You can't just, 0 is a perfect starting point. Because they have to be, if you look, the subnets here are in perfect increments or multiples of 32. And they have to be that way by design. You can't just pick something in your head and say, okay, I'm going to start the first network in 192.168.1.8. That's not a valid network with this subnet mask. It's 1.0. So you start with 0. 0 is the perfect starting point. And then you just increment in the value of 32. You always go past where the actual host number is, 124. You go past 128. Once you go past, it's always the one before it. So you need to go past in order to find out where it is, if that makes sense.
Mm-hmm.
So any questions on that? Okay. If you won't do that one, just give me that one for a sec. give me a second here. We'll do it, but I'm going to make it a little bit easier. So, take that. Okay. So I'm going to have two PCs here. And I'm going to call them Tom and Bob. Okay. So we've got Tom over here. Okay, this is one I want you to do. This is Tom. And Tom's IP address is 172.16.68.65. And you got a switch. And you got Bob over here. And Bob's IP address is 172.16.68.62. Now, the subnet mask of Tom is 255.255.255.240. And same over here, 255.255.255.240. Now, before we look at this question, what class is this? Is it a class A or a B or a C?
Class B.
C.
What did he say was the only requirement for a network to be in its specific class?
First octet.
First octet, that's it. That's all that matters. So here, Tom is 172. 172 is between 128 and 191, so it's a class B. Always a class B. They're the requirements that indicate class A, B, or C. It's where the first octet lies.
Yeah.
Okay, so I'm going to get used to do this question. And basically, you've got Tom and you got Bob, and they've already been subnetted. We know they've been subnetted. How do we know they've been subnetted? Because they're not using their class full. This class full is their original subnet mask. Because Tom's, this is a class B, and the starting out subnet mask for class B is 255.255.0.0. So the fact is they're using a different subnet mask tells us that it's been subnetted. If you see an IP address and a subnet mask that is not the same as its normal default class, that means it's been subnetted. That means the subnet has been changed to give us more or less networks. Okay, so my question here is Tom and Bob on the same subnet? We've connected to a switch. By the way, don't answer. I want you all to do it. So what you have to do here is, there's a few things I'll write down. So you have to find the increment value. And we've been doing all of this yesterday, and use the increment value to write network ranges. That's all. Find the increment. Once you find the increment, everything else will fall into play. Okay, so we'll give you maybe 5 or 6 minutes to do that, yeah? Let me know how you get on. I'll pause the recording here while you are doing it. All right, record. Okay, so find the increment value. Just and then use the increment value to write their network ranges. Okay, so just stick this in here. There we go. All right, so the increment value here is, well, again, use that quick calculation. You have 256 minus 240. So the increment value is 14. Yeah. So, sorry, 16.
16, Jesus.
16, yeah. So that means your subnets will increment in the value of 16. Yeah. So where do you start? So our increment is 16. You start at 0 because 0 is the perfect starting point. Okay. So you write subnet number 1. Now you don't have to do all the subnets. You go through this real quickly. 172.16.68.60, 68.0, 68.16, 68.32, 68.48,
56.
64.
Sure.
Yeah. Okay, so 0, 16, 32, 48, 64. Okay, and then you can keep going and you get to 68.80. Okay, so the ones we're looking for is, we're a bit down here, this one here. So which is what? Hold on, let me just, I better just fill this in here. Subnet number 2, 172.16. Subnet number 3, 172.16. Subnet number 4, 172.16. Subnet number 5, 172.16. Okay, so where does Bob live in?
48 network.
Bob lives where?
The 48 network.
The fourth network, yeah. Yeah, or the 48 subnet, yeah, yeah. So the 17, so Bob lives here. And where does Tom live?
64 network.
Yeah, on the fifth network. Yeah. Will they be able to talk to each other if they had a switch here?
Yeah.
Will they?
No.
No, because they're in different subnets. Bob lives in the fourth subnet. Tom lives in the fifth subnet. A switch won't work. They won't be able to talk to each other because the switch only provides communication. What's that? So if Tom wanted to talk to Bob, what would they need?
A router.
A router. Yeah, because routers provide communication between devices in different networks. They don't have a router, it's a switch, so therefore they wouldn't be able to communicate with each other.
Will they be able to talk to each other with level 3 switch?
Yes, they would, because a layer 3 switch is actually more like a router, because a layer 3 switch is a default gateway. And we will look at layer 3 switching in, I don't know, so many weeks. It's one of our topics. Okay, all right. Oh. Cool. So we can even check that out. Okay, let's have 2 PCs here. So Tom and Bob, grab a switch. I'll give it bigger. Oh, that's too big. And so put in here 172.16.68.65 and 62. Okay. 255.255.240. I have to put in the subnet mask for some reason first. 172.16.68. 62, wasn't it? 68, 65 and 68, 62. Over here, 255.255.240. 172. God, why does that happen all the time? 255.255.240. 172.16.68.60 or 62 and 65.
62.
65.
Yeah, the other one 65. There we go. Sorry about that. And it's not going to work anyway. 172.16.68.65. Oh, that's I'm pinging myself. 62. Yeah. Okay, I'm pinging the other device over here. This guy over here, it's not going to work. Yeah, of course I can ping myself, but I'm not going to be able to ping the other guy. Okay, so I'm going to get another question thrown up there for you. Again, same format, a little bit different. Let's see. Let's see here then. So okay. 192.168.1.49 slash. I'm going to give it a slash notation. 1.49 slash this guy over here. 192.168.1 dot. Actually, well, I won't do 49. Give me a second. I'll do something a little bit different because it just takes a bit too long. 192.168.1 dot. One 192.168.1 dot. There we go. Okay, Tom and Bob, I'm not giving you a subnet mask. You have to figure that out for yourself from the slash, from the side of notation. So I've got Tom's IP address 192.168.1.17, Bob's IP address 192.168.1.14, but their subnet mask is given inside a notation, which is /29. So again, you have to find the increment, but before you find the increment, you have to find the subnet mask from the slash notation. Once you find the subnet mask, you'll be able to find the increment. Okay. Is that okay with that? How we go with that one there? Let's have a look at it. Okay. So when you see a /29, you have to kind of say, you have to ask yourself, what does a /29 mean? So a /29 means that you have 29 subnet bits. So you better off drawing them out. So /29 is 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now there's /24, which is the normal subnet mask for a class C, but we're taking 5 of these zeros here and we're changing them into ones. So we're going to do 1, 2, 3, 4, 5, and then we're going to have left over. That's what a /29 looks like. So any questions on that? 8, 16, 24, 25, 26, 27, 28, 29. So what's your increment value? 128, 64, 32, 16, 8, 4, 2, and 1. So your 1, 1, 1, 1, 1 is 1, 1, 1, 1, 1. And then you have 0, 0, 0. So what's your increment value?
8.
8. The increment value is 8. So that tells us that each subnet will increment in the value of 8. Okay. So any questions on that, guys?
No.
Everyone's good?
Mhm.
Okay. So now, using the increment value of 8, use the increment value of 8 to write down your subnets, your new subnets. So where do you start? You start at the start. You start at 192.168.1.0 because 0 is the perfect starting point. Okay, so subnet number 1. One 192.168.1.0. Subnet number 2, 192.168.1.8. Subnet number 3, 192.168.1.0. 16, subnet number 4, 192.168.1.24. Where are we going as far as, well, where is, so which ones are we here? So where's Bob? And where's Tom?
Tom is
Four, please.
1, 2, 3,
943.
Tom's 4.
So Tom is in subnet number 3. And Bob.
Oh, sorry. Yeah, sorry.
Because subnet number 2 is going to go as far as 192.168.1 dot.
Sorry, the 29 at the end was drawing me there. Sorry.
Or the 24, is it? Yeah. Oh, the slash 29.
Yeah, sorry, just drawing there. Sorry.
That's all right. Because remember, our increment value is 8.
Yeah.
Means our subnets will increment in the value of 8. So 192.168.1.15. So yeah. Okay, any questions on that? Is Bob and Tom on the same subnet?
No.
No, they won't be able to talk with each other.
But can you find the subnet from using that grid?
From what? Find what
As in
subnet?
using your 128.64.32.16.842 and 1. Obviously, when you find the increment
Yeah.
and you
Okay.
add the increment into your grid and then you tally up the
So what? Yeah. So will you tell me the subnet? I can find it.
225.225.248.
That's it. Yeah. Yeah. Because so 128, 64, 32, 16, 8, 4, 2, and 1. And all you're doing is doing 1,
Yeah.
1, 1, 1, 1,
1,
0,
3
0,
0 zeros.
0,
You,
and add them up.
you do the same for both of them and you get the two different subnets.
Both of them are in the same subnet. Both of them are in 255, 255. So they're in two different subnets. Yeah. Yeah.
That's it. Very good.
It's the same subnet mask, obviously. Yeah.
Yeah.
But they're in different subnets. Bob lives in the subnet number 2 because his address is 192.168.1.14. Tom is 1.17.
Yeah.
So even though they're 3 addresses away, they're in different subnets. They won't be able to talk to each other if we just have a standard bog standard layer 2 switch time. Okay, I want to have another one. Just throwing them all out here now, which is well able for them. One 172.16.
You try to catch that by using the first and last.
Well, we'll see now. Give us a subnet. Okay, is Tom and Bob in the same subnet? Again. All right. Right. So we got /22. So we need to find the increment. We have a /20. We need to find the increment. So again, /22 means you've got 22 subnet bits. 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 8, and 8 is 16, and 6 is 22. Dot 0, 0, 0, 0, 0, 0, 0, 0. That's what a /22 looks like. Where is the increment, or what is the increment? The increment is always the last subnet bit converted into decimal. If I take this value here, we say 128, 64, 32, 16, 8, 4, 2, and 1. And we have 6 of these ones, don't we? So we say 1, 2, 3, 4, 5, 6. The increment value is what?
4.
4. Now, where is the increment value in? What octet?
Third octet.
The third octet. This is the first one. This is the second. This is the third. And this is the fourth. There's no value in here. There's no increment there because they're all zeros. So the increment is in the third octet. It's number 4 in the third octet. So this means our new subnet will increment in the value of 4 in the third octet. Yeah? So, okay? Okay, so we start writing our subnets down. So we say subnet number 1, we bring everything back to 0. But the thing is, where do we bring it back to 0? Well, if it's 4 in the third octet, so you bring the third octet back to 0. So you say network number 1, 172.16.0.0, because if the increment is 4 in the third octet. Network number 2, 172.16.4.0. Subnet number 3, 172.16.8.0. Is Tom and Bob any valid addresses? 172.16.3.0, is that a valid address?
No.
No.
It is.
Yeah, it's both there.
Both of them are because they're valid because the subnet mask makes them valid. If you think about subnet number 1, what's the very last address in network number 1? It's going to go as far as
3.255.
16.3.255. And subnet number 2 is going to go as far as 172.16.7.255. So yeah, so Tom lives here and Bob lives here. But again, the only conditions for these devices is that they can't be the very first address in the network and they can't be the very last. 3.0 is not the very first address in network number 1. It's right in the middle. And 4.255 is not a broadcast. It looks like it's a broadcast, but it's not, because the subnet mask, the subnet that Bob lives in, the network ID is 4.0. You can't use that, and you can't use 7.255. But everything else in the middle you can use. All right.
So basically, there's 1,024 addresses between each subnet.
There is, yeah, there is, yeah. 8 bits, 10 bits, yeah. 2 to the power 10 is 1,024, yeah, there is. Yeah, well done. Okay, any questions on that, guys? Right, okay.
No.
I'm going to, there's a couple of different things that you can do. There's another a good website called, if it's still up, it's been a while since I went to this one. Yeah, it is. Subnettingquestions.com. Okay, subnettingquestions.com. I'll put it on the chat here. I'm still using HTTP, huh? Okay, so we could do this one here. Let's see if I can make it a bit bigger. Okay, I'm just going to do it. Have a go at that one there, guys. This will be the last one we're going to do. One second, I'm going to just clear everything here. Put it in here so I can write on it. Okay, so it's done. Oh. Paste it again. Sorry. So what is the last valid host on the subnet 172.31.120.0/23? Really ads, not free. Okay, well, let's do this one. So it tells us that this is a subnet, okay, of 172.31.120.0/23. It tells us that it's a subnet, okay, and it is a subnet. So we have a /23. So what's the /23? /23 is 1, 2. Actually, I'll just do it in black. 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7. 0. 1, 2, 3, 4, 5, 6, 7, 8. That's what a /23 looks like. 8, 16, 17, 18, 19, 20, 21, 22, 23. You've got 8 bits here, you got 8 bits there, you got 7 1 bits there, 8 and 8 is 16 and 7 is 23. Yeah. So what's the increment value? Increment value is always the last subnet bit compared to the decimal. 128, 64, 32, 16, 8, 4, 2. Our increment value is 2. In what octet?
In the
Third octet.
Third octet. Yeah.
yeah.
Because it's in the third octet. It's a 1. Again, the increment value is always the last number 1 bit in
Whatever octet.
whatever octet it's in. So it's here. Put a circle around it. It's in here. So it's 2. Okay. So it says, what is the last valid host in the subnet? Okay. Well, it tells us that this is a subnet, right? The question says this is a subnet. 172.31.120.0. Okay, so that's a subnet already. So 172.31.120.0. And what's the next network after that? If the increment is 2, the next network after that is going to be
122.
172.31.122.0. Now, how far is this network going to go as far as?
121.255.
Yeah, spot on. So this is going to go as the broadcast address will be. No, God, 1 second. 172.31.121.255. So the very last valid host is what? In the subnet. What's the last valid host?
254.
172.31.121.254. Yeah. Let's check it out. Does that make sense? Any questions?
Oh, good.
So 172.31.121.254. One 172.31.121.254. Clear as mud. Now be careful on this. What I will do is go through with some of it. Some of it is can be a little bit confusing. You need to have a calculator with it. But if you have any questions, let me know. Send me a screenshot, and I can go through it next week with you. Also, there are. Let me open up this here. There is homework you can do. There's a table on the Dropbox link under the course materials. Just get it here. So under here, day 4, subnetting homework. So if you have a look in here, it's a PDF. So you got the exercises and you got the exercise answers. So the exercises, I'm just opening it up here. It's got 2 tables. So it's giving you have to fill out, complete these 2 tables. Go away. First IP address, second IP address, are they in the same subnet? that's very similar to the ones what we're doing today. Same format. And then it gives us an IP address and a subnet mask, and you have to determine the subnet and the broadcast address of the network for these devices. So have a look at those. The answers are there on that sheet. If you do come across anything that makes no sense at all to you, take a screenshot and send it on to me in an email or something, or and we can have a look at it next week. Okay. What I'll do is I'll divide a little bit of time towards the class next week to look back over subnetting.